Hi, today we are going to use our genius to create a pranking device. One that senses you passing by and creates a massive sound and light of an explosion, which is created by exploding something. I figured is easiest. I'm not an explosive expert, but I've blown enough capacitors in my time. If you apply a voltage higher than its rating, it will blow up. Like so. Oh, not plugged in. Like so. Ow, shit. Ow. Of course, if I'll be running it from the mains power, it will be dangerous, so you must not repeat this. But it will make for a good educational video. Now, to switch the high voltage over the capacitor, I'll be using a 5-volt relay. I can connect the power through the switch to the capacitor that is connected to the normally open contact of the relay. So when I apply 5 volt to the relay coil, the switch closes and bang! Let's give it a try. We just need to follow the relay's datasheet pinout to connect the wires correctly. Oh, it says bottom view. I thought it was top view and connected the circuit to the normally closed contact, which connects the capacitor to high voltage right away. Let's try it again. Okay, all good. Now if we connect the 5 volt to the relay coil, it should blow up. The hell? When you want it to blow up, it doesn't blow up. When you don't want it to blow up, it blows up. What is going on? Ouch! The relay contact was welded short. See, I thought because my capacitor was 10 microfarad, its impedance at 60 Hz would be around 260 ohms, which at 120 volt AC would draw less than half an amp. But that's wrong. These capacitors behave kind of like this, conducting much more current outside the rated voltage. So although my relay is rated for 2 amps, when the capacitor blows, it draws a lot of current, fusing the relay contacts short. So the first time I accidentally connected to normally closed contacts, they were already fused. And when I flinged it, I broke it open. So I guess after every use, I'll have to fling the relay to make sure the contacts are not fused. Or pick a higher rated relay. Yeah, I'll just fling it. Now I need a sensor, and for that I pick this photocell or photoresistor, which basically changes its resistance based on the amount of light it receives. The plan is, if somebody passes casting a shadow on the sensor, we want to detect it, switch the relay, and BAM! So I place the photoresistor in series with another resistor between the 5 volt supply. This is a voltage divider which creates an output proportional to the resistance values. So this voltage changes as the amount of light changes. I place these on my brand new breadboard that comes with 3 power supplies and 2 voltage and current meters. These are parts of a bundle I put together with circuit specialists to provide electronic enthusiasts with some good low-cost equipment to start their journey. I'll explain it more at the end if you need one. Now you see, the voltage is changing, and instead of a fixed resistor, I'm using a potentiometer because this way I can change the threshold between shadow and light based on the room lighting. Now I feed the voltage into a BJT transistor, and because the transistor might be drawing too much current from its base and affect the voltage reading here and affect the gain, I place 2 transistors in this configuration called Darlington. I explained to you in my ElectroBOOM 101 how BJT transistors work. Go watch that one afterwards. Fortunately, nothing went wrong in that one, so it didn't get many views. But I'm putting my life on the line in this one, so you better like and subscribe now. But basically, the collector current is much larger than the base current by a factor of beta, which for my transistor is around 200. But in this Darlington configuration, the 2 transistors together function like one transistor, with their overall beta equal to the product of each transistor beta, which will be very large, like 400,000, and the base emitter on voltage would be around 1.4 volts. Okay, now the circuit is together, we tune it with the potentiometer. You hear it? Okay, let's connect the capacitor to the circuit. Okay, good, good. The circuit is off, the light is on, so it's not gonna blow up at the beginning. Oh, the photocell resistance reduces with light. So it pulls the voltage up, turning the transistor and relay on. But in my application, I need the switch to be off when there is light, which means instead of normally open, I should be connecting to normally closed contact. Wow! All right. Well, if the 5-volt supply is off, the relay won't switch and stays on normally closed at the beginning, even if there is light and the capacitor blows. So I have to connect it back to normally open contact, but switch the place of the photoresistor and potentiometer. Now when there is light, photocell resistance is low, pulling the base voltage down, keeping the transistor off, until someone casts a shadow on the sensor, raising the resistance and base voltage, turning the transistor and relay on, and bang! Ouch! My relay died. Have to pick a stronger relay. This relay can do 40 to 60 amps, but I have to run the circuit on 12 volts, which is fine. Let's turn the circuit into something usable. I'm gonna solder all these onto a board first. You know, I think it is safer to add an LED to the circuit as well, so we know when the relay is switching the live voltage to the capacitor. Always look on the bright side. Like so, I'm using 2 alligator clips to hold the capacitor so it's easier to replace and reload. And I added an LED too. Now I'm sure everyone can find an old wall adapter in their old stash of wall adapters. I have this 12-volt one and we cut this open. Now we have access to both the 12-volt supply and the 120-volt contacts. So we solder our circuit on. Life is a piece of shit when you look at it. And what a beautiful product. Let's try it. Also, for added accuracy, I put a cone around the sensor so it's more directional towards a certain light. First, we plug the circuit in without a capacitor to tune it. With the sensor pointing to the light, we tune the potentiometer until it just turns off. Like this. See? It switches. Now that it is off and safe, we place the capacitor. Oh, damn it. Phew. Good thing I put the LED in to tell me when the circuit is on. So we unplug it first, put the capacitor in, then plug it back in. What? Ow. This project is hell. Okay, so we plug it in without blocking the light. Okay. بیا اینجا نگاه کن، چیه؟ جوهر قرمز ریختن رو صفحه داغون شده. بیا نگاه کن.
مهدی به خدا میکشمتونا.
Piece of shit. Well, at least I hope you learned some electronics. Just remember, you can always start at safe levels with these tools. For a long time, I was thinking it would be nice if there was a bundle of basic electronic tools and components I could offer to people so they could start on their electronic journey easily. And now there is. Circuit specialists and I put together a great bundle that includes a large breadboard that includes 2 variable power supplies with embedded voltage and current meters, a whole lot of basic electronic components to play with, a ton of jumper wires cut for breadboard, a digital multimeter, and a few ElectroBOOM speakers, which are very important for your circuits won't work without them. And the whole kit is only $200 and is available globally. Just that if you buy it from outside US, you will probably be slapped with some import fees and duties. It is still a good price, so get it from the link in the description. We can use these together in my ElectroBOOM 101 series to learn about electronics. Or you can get it as a gift for someone who loves to play with electronics. Do it now!